Okay, here we go with our next lesson. Today we are going to talk about solving some basic equations and some basic inequalities. And again, this is meant to be a review so that we do not have to take up valuable class time in August with this. So just as a reminder, a linear equation has a standard form of y equals mx plus b, where the m is the slope and the b is the y-intercept. Okay, when we talk about the solution to an equation, we're referring to the place where the graph crosses the x-axis. That's what we refer to as the solution to the equation. So one way that we can find the solution to the equation is by setting it equal to 0. Okay, so let's just go ahead and let's just review some very, very basic solving equations, okay? So let me just clear this screen. All right, so let's look at 2 times 2x minus 3 plus 3 times x plus 1 equals 5x plus 2. Now, in order to solve this equation, I have to combine my like terms. So I'm going to start by distributing. So we'll distribute that 2, and we get 4x. 2 times 2x is 4x. And then we'll distribute the 2 to the negative 3. So 2 times negative 3 is negative 6. And then we're going to do the same thing over here. We're going to distribute the 3 to both the x and the 1. It has to be distributed to everything inside the parentheses, so that's going to give us 3x plus 3, and that equals 5x plus 2. Okay, we're going to combine our like terms. So I've got 4x and 3x on the left side here, so we've got 7x, and then we have negative 6 and positive 3. Negative 6 plus 3 gives me negative 3. So we combine like terms on each side. Now we're going to move everything over to all the x's to one side and all the numbers to the other side. So I'm going to subtract 5x from both sides. Now I could have subtracted 7x. I chose to subtract 5x because I like my x to be positive. So we get 2x minus 3 equals 2. So now I'm going to add 3 to both sides. Again, I want to get all the x's to one side and all the numbers to the other side. So we have 2x equals 5. Okay, now how do I get the x by itself now? Now I'm going to divide by 2 on both sides of the equation. So we have x equals 5 over 2. That is the solution to that equation. Now if I go back up to the original equation, remember I said the solution is actually where it crosses the x-axis. So if we wanted to find the solution to this, we could rewrite this with everything on one side of the equation. So that means I'll subtract 5x from both sides, and I'll subtract 2 from both sides. So we're going to get minus 5x minus 2 equals 0. So I'm looking to find where this whole thing is actually equal to 0. And according to the work I just did, that's at 5/2 or 2.5. How could I check that on my calculator? Well, there's two ways. First off, I'm going to put the entire thing in y equals. So we have 2 times 2x minus 3 plus 3 times x plus 1. And then remember, I subtracted 5x and I subtracted 2. This whole thing has to equal 0, which means when I graph it, I'm looking to see where it crosses the x-axis. Well, it crosses the x-axis at 2.5. Now, if I do a calculate 0, okay, I'm going to do a calculate 0. There you have 2.5. Now, there's a link in the description section of this video to the calculus videos, or the calculator videos, I should say. In the calculator videos, I have a video on how to find the zeros or the x-intercepts. If you don't know how to do what I just did, you need to watch that video. They're all pretty short videos, but it's very, very important that you know how to do that. I do not want to spend time in class going over how to use a calculator. So you should know that. Okay, I'm going to show you again very quickly. I did a calculate 0, right? And I have to pick a left bound, and then I have to pick a right bound. And again, in the video link in the description section of this video, there's a link to the calculator videos. Okay, it wants a guess now, so I'm going to guess, and it gives me the answer. This number means 1 times 10 to the negative 12. That means it's got a decimal point and then 12 zeros, which means it's an extremely small number. So we count this as a 0. Anytime I'm looking for an x-intercept, the y will be equal to 0. Okay, let me just show you that again, right? If I'm looking for an x-intercept, that means I'm looking to see where it's crossing the x-axis. Well, anything on the x-axis will have a y value of 0. Look, this is 1, 0. Here we have 2, 0. This is negative 1, 0, right? Anything on the x-axis has a y value of 0. Okay, these all have y values of 0. So when we graph it on our calculator, we're looking to see where the y value is 0. Okay, another way of checking this on the calculator, if you remember the equation, the original equation, let me just erase this. We have 2 times x minus 3 plus 3 times x plus 1. And we said that that was equal to 5x plus 2. So what we can do on our calculator, right, we're going to put the left side in y1, and we're going to put the right side in y2, 5x plus 2. And we're going to look to see where they are equal or where they intersect. Now, I can't see it on my screen, so I'm going to adjust my window. Change my x max. I'll go up to 20 on my y value rather. Change my y max. Okay, so now I can see where they're equal. They're equal right here. That's where they intersect. So I'm going to do a calculate intersect. Again, in the calculator videos, I teach you how to do this. Okay, I'm going to come up here, press enter, and look at that. It tells me it intersects at x equals 2.5. Okay. Okay, so that was just a basic linear equation. You should know how to solve a linear equation in this form that requires multiple steps. We had to distribute And then we had to combine our like terms. And then we had to move all the values that are not x's to the other side, right? We had to isolate the x. That's what we call that, isolating the x. Okay? Okay, so let's look at one that's a little more complicated. Let's say that we have 5x minus 2 over 8 equals 2 plus x over 4. So let's try to solve that one. Okay, so this one's a little trickier. So the first thing I want to do is get rid of those denominators because they're kind of making it messy and ugly looking, right? So what can I do to get rid of the denominators? Well, I can multiply by the greatest denominator. Okay, so what is my greatest denominator? 8. So I'm going to multiply everything by 8. Okay, so over here I'm going to have 8 times 5x minus 2 over 8 equals, we're going to do 2 times 8 plus 8 times x over 4. So these 8's will cancel. So I have 5x minus 2 equals, right, 2 times 8 is 16 plus, now this 8 and this 4 will reduce, and that's going to reduce to 2x. Now I just have a basic linear equation. So again, we want to isolate the x. So let's get all the x terms over to one side. So I'm going to subtract 2x from both sides. And we get 3x minus 2 equals 16. Again, we're trying to isolate the x to get the x all by itself. So we're going to add 2 to both sides. So we have 3x equals 18. And then we'll divide by 3. So we get x equals 6. Okay? X equals 6. If I go back up and just double check that answer, right, I had 5x minus 2 over 8 equals 2 plus x over 4. So let's substitute our 6 in there. 5 times 6 minus 2 over 8 equals 2 plus 6 over 4. Don't get scared of the fractions, right? 5 times 6 is 30 minus 2 over 8 equals, let's get a common denominator here. So let's make this 8 over 4 plus 6 over 4, right? 2 is the same thing as 8 over 4. So now we have 28 over 8 equals, right? We're adding fractions, so we add the top. 8 plus 6 is 14 over 4. Are they equivalent? Well, let's get a common denominator again, right? Let's make this an 8. So that means I multiplied by 2, so the 14 becomes a 28. So here I have 28 over 8 equals 28 over 8. They are equal. So that worked. Okay? So again, when we started the problem, we had these ugly fractions. So in order to get rid of the fraction, I multiplied by the denominator, right? And my greatest common denominator was 8. So I multiplied by 8. Okay. What about inequalities? Inequalities means they're not equal. So something like 3x minus 1 plus 2 is less than or equal to 5x plus 6. So again, we want to get all the x's to one side, so we want to isolate the x's. So let's start by distributing. So we get 3x minus 3 plus 2 less than or equal to 5x plus 6. Okay, I'm going to combine my like terms here. So 3x minus 1. Okay, now I handle these a little bit differently than equations. And what I mean by that is with the equation, I don't care what side the x is on. With an inequality, I do. When we're dealing with inequalities, I want you to leave the x on the left side, okay? I'm going to write it out here. Keep the x on the left. I know some of you are in the habit of not doing that, and you're going to say, but it works for me. I don't care. I want it on the left side, okay? All right, so that means I'm going to subtract 5x from both sides, and that's going to make this negative, but that's okay. We'll deal with that. Negative 2x minus 1 less than or equal to 6. So then we're going to add 1 to both sides, so we get negative 2x less than or equal to 7. Now we're going to divide by negative 2. We're dividing by negative 2. Now, does anyone remember what we do with an inequality when we divide by a negative number? We flip the inequality. So this becomes greater than or equal to negative 7 over 2. Okay, I want the x on the left. I know that it feels like it would be easier if we had subtracted the 3x because then we wouldn't have to flip the inequality. I know that. I don't care. I want the x on the left. Okay. Now with inequalities, we're going to graph our solution on a number line. So we're going to draw a number line. Okay. We're going to put a 0 on there. I'm going to use that kind of as our reference. And then we're going to put where the solution is, negative 7/2. Okay. Now, the reason I want the x on the left is that it makes it a whole lot easier to graph the solution. Okay. The solution is all x's that are greater than or equal to. Well, if you look at the direction this is pointing, that's the direction our arrow is going to point. Okay, so we're going to go greater than or equal to, so everything going this way. Now, in the old days, in the Algebra 2 days, the way we graphed it was we put a solid circle here, and then we said, okay, everything going that direction. Well, now we're going to use a slightly different notation. Instead of using a circle, I'm going to use a bracket. A bracket like this. And then I'm going to point my arrow this direction. Okay, this is the same thing as what we learned in Algebra 1 or Algebra 2, right? Of a closed circle pointing that way. But we're using the bracket. So the closed circle is a bracket, right? An open circle would be just like a parenthesis like that. Okay, so parenthesis means open circle, bracket means closed circle. What do they actually mean? The bracket means we're doing everything right up and including the negative 7/2. Okay, the bracket means we include the negative 7/2. If it was a parenthesis, we do not include the negative 7/2, but we get as close as possible. Okay, for instance, let's just say that we had a solution that looked like this. Let's say that this was a 3, right? And we're gonna have a parenthesis like this. Okay, what would this mean? This means that I've got everything that is less than 3. So that means 2.999999999, right? Just keep going as close as you can possibly get, but not including. Okay? So the parenthesis means it does not include the number. The bracket means it does include the number. Okay? Okay, another way of representing this is using what we call interval notation. Okay, interval notation. So instead of writing the answer in this form, x is greater than or equal to -7/2, or writing it graphically, right? These are two different ways of representing our answer. We can represent our answer in what we call interval notation. And in this case, right, this is all x's that are greater than or equal to. So I'm going to put a bracket because we're including -7/2. Everything that's greater than then. So what's the biggest number I can use? There is no biggest number, right? So we're going to say to infinity. And then we're going to put a parenthesis there. So why am I putting a parenthesis? Well, because we can never actually equal infinity. Infinity always has a parenthesis. We never use a bracket with parenthesis, right? So how would I write this solution in interval notation? Let's see here. We're going to go from 3, and we'll put a 5 there, and we're going to put a parenthesis, and we're going to put a bracket there. Right? What does this solution actually represent? Everything between 3 and 5. Does it include the 3? No, it does not include the 3. Does it include the 5? Yes, it does. So in interval notation, it will look like this. Parenthesis 3, comma 5, bracket. That's our interval notation. Okay, what about this one? We're going to go, let's see. We're going to use a parenthesis. Okay, how would I represent that in interval notation? Well, it's really actually pretty easy when you look at the bracket and the arrows, right? We're going to go from -infinity, right? Because it's going from 4 and then everything below it, comma 4. I do not include the 4, so I'm going to use a parenthesis. So everything from 4 and below. Okay, one more. So we're going to put a bracket here. Okay, what's that going to be in interval notation? So this is everything greater than or equal to -2 to infinity. That would be our solution in interval notation. Okay, one more example. Let's solve this inequality. We've got -3 less than 2x plus 5 over 3 less than or equal to 5. Okay. Now this looks really tricky to solve, but it's actually pretty simple. Remember, what is our goal? We want to get this x by itself. We want to isolate the x. So the first thing I'm going to do is try to get rid of this 3. Well, we're dividing by 3, so how do I get rid of it? I'm going to multiply everything by 3. So this becomes -9 less than. Now what happens when I multiply by 3 inside here? These 3's are going to cancel. So we have 2x plus 5 less than or equal to. I multiply the 5 by 3 also. So that becomes 15. Okay, now we're going to continue to try to get rid of everything except for the x. So we're going to subtract 5, but we have to do it everywhere. So this becomes -14 less than 2x less than or equal to 10. And then I'm going to divide by 2. Remember, we're trying to isolate the x. So now we have -7 less than x less than or equal to 5. There's my solution. What's that look like on a number line? Well, see, I like the solutions when they're written in this form because it makes sense to me. The x is between -7 and 5. So let's put our -7 there. Let's put our 5 there. Okay. Does it include the -7? No. So we're going to put a parenthesis there. Does it include the 5? Yes. So we'll put a bracket there. And it's everything in between. There's my solution set graphically. What would that look like in interval notation? We're going to go from -7 to 5. We do not include the -7, so we put a parenthesis. We do include the 5, so we put a bracket. Right? So I've represented my answer 3 different ways. I've represented it just as an inequality. Here we have interval notation. And here we have graphically. Okay? Okay, so we're going to stop there. In the description section of this video, okay, in the description section, let me just write this out for you. Okay, so in the description section, first off, we have calculator video link. Okay, and then there's also a link there to a worksheet that I want you to complete. Okay, there's a link to a worksheet that I want you to complete. Again, I will be expecting you to hand these worksheets and practice problems in the first week of school. Okay? All right. See you in the next video.